For this video, we'll be discussing 1-1 and 1-2, which is order of operations and evaluating expressions. To start our notes here, we have a very large vocabulary section. Something I want to make crystal clear is that you will have a vocab section on your test, so it will be extremely important that you study your vocab, that you know your vocab. This can be flashcards, making your own set of Quizlet, like a Quizlet deck or whatever. Something that helps you study these vocab words, because again, like I said, there will be a section on your test where you will have to match vocab words with definitions. So, getting started here, first vocab word, when n is a positive integer, the exponent indicates the number of times a number is multiplied by itself. Then we have in a power, the base is the number being multiplied by itself. So if we were to talk about both of those as an example, a base, for example, could be 4. Let's actually switch this to green. So that would be our base, and then our exponent could be to the 7th power. So this would mean that it is 4 times itself 7 times. So it would be 4 times 4 times 4 times 4 times 4 times 4 times 4. Next we have, let me switch back to my highlighter here, we have to evaluate an expression means to find its value. If a numerical expression contains more than one operation, then the rule that lets you know which operation to perform first is called the order of operations. Next, we have a variable is a letter used to represent an unspecified number or value. The term of an expression is a number, a variable, or a product or quotient of numbers and variables. And then next we have a variable term is a term that contains a variable. And then we have a constant term is a term that does not contain a variable. Now, moving on here, we do have a key concept. We have order of operations. This should hopefully be extremely familiar to you, but so I guess we'll go ahead and just say it right now. This is referring to what we all most commonly know as PEMDAS. However, there are just a couple of key things to remind you of. So step 1 says evaluate expressions inside. This would be grouping symbols. I know a lot of us are used to saying parentheses, but parentheses are just one of many grouping symbols. In this class, we will see grouping symbols such as parentheses, like we just talked about. We will also see brackets. We will also see absolute value bars. So those are the 3 types of grouping symbols that we will see in this class. Next we have, so I guess in reality, this is technically your P of PEMDAS. Step 2 would be the E of PEMDAS, which would be evaluate all exponents. Some people also say powers here, which is the exact same thing. And I'm actually going to move this up just a little bit here. Okay, step 3 is going to be our M and our D of PEMDAS. So step 3 is multiply and or divide. But this is probably the biggest mistake of PEMDAS that people make, is multiplying and dividing happens from left to right. Just because the M comes first in PEMDAS does not mean that that's actually the operation that necessarily has to happen first. It all depends on it being from left to right. After that, we have step 4, which would be the A and the S of PEMDAS. So this would be add and or subtract. But again, biggest mistake people make is they don't follow that left to right rule. And we will talk much more about this when we look at our examples here. So I will leave those at the top there. Okay, going ahead and getting started here, it says simplify a numerical expression using order of operations. Our goal here is to get each of these expressions down to one final number for our final answer. So looking at number 1, going through PEMDAS here, I don't see any parentheses. I also don't see any exponents. So then I'm going to go straight into step 3, which is multiplying and or dividing from left to right. I do see multiplication, so I'm going to be multiplying 6 times 3. So I'm going to bring 2 minus down. I'm not using that at all yet. 6 times 3 would be 18, and then I'm going to bring down the plus 1. Then after that, we are now onto adding and subtracting, but again, we have to go from left to right. I do see adding and I do see subtracting, but according to the rule, going from left to right, I am going to subtract first. So I have 2 minus 18 would give me a negative 16, and then I'm going to bring down that plus 1. And then my final answer, if I add negative 16 and 1, I would get negative 15. Moving on to number 2 here, I do see parentheses, so we are going to work inside of those parentheses first. So I'm going to go ahead and just make those pink to follow my colors up above. So inside, I see subtracting and I see multiplying according to PEMDAS, which, by the way, does start over when you start a set of parentheses. So inside of the parentheses, we go back to the very beginning. I would multiply first. So I'm going to do 2 times 3 here. So I'm going to bring down the parentheses, and the 4 minus 2 times 3 is 6. And then I'm going to end the parentheses and then bring down that plus 5. Something I don't think I've mentioned yet, I do make you show all of your work. So every single line, I want to see what you're doing. You don't have to underline like I'm doing. That's more so for your notes to be more helpful so that you know what I'm doing each time. But you do have to show all of your work. You can't just plug this whole thing into your calculator, slap an answer on the paper, and call it good. You have to demonstrate to me that you do know the order of operations here. So showing your work will be a requirement. The other thing I want to make sure I make very clear, you cannot drop the parentheses until you have one number inside of the parentheses, and then at that point you can drop them. So the reason I still have them on the line that I just wrote is because I still have a 4 and a 6. Those are still two numbers, so I can't drop these parentheses just yet. However, now I'm going to do the 4 minus 6. So then since I'm going to get negative 2 here, and that is a singular number, I'm going to go ahead and not bring the parentheses down, but then I am going to bring that plus 5 down. So then my final answer here would end up being 3 when I combine those together by adding. Looking at number 3, again, I see these parentheses right here, so we're going to have to take care of that first. Luckily, there is only one operation to do on the inside, so we're going to go ahead and do 6 minus 2. That gives me a 4, and since I do not have any other numbers, I can go ahead and drop the parentheses, but I do need to bring the third power down and then divide it by 2. And then after that, remember, we're still only on the P of PEMDAS because I did the 6 minus 2. Yes, that was subtraction, but that was just to take care of the parentheses first. So now we're going to do our exponent here. So 4 to the third power is not 12. It is not 4 times 3. It's 4 times itself 3 times. So it's 4 times 4 is 16 times one more 4 would be 64. And then I'm going to bring down that divide by 2. And then we're going to divide at this point. That is the last operation to do here. So then 64 divided by 2 would give me 32. Okay, moving on here. Looking at number 4, I see that we have a fraction here. A lot of people get stressed out when they see a fraction. The biggest thing I need to make very clear here is fractions are really not the end of the world. It just means you're dividing, but we can't divide until I get one number on top and one number on the bottom. So we're only going to focus on the top, and then we will focus on the bottom, but we will not do anything with that fraction until the very end. Now, the nice thing about the numerator and the denominator, the top and the bottom, is we can do them both at the same time, just making sure we follow order of operations correctly here. So I'm going to erase those two circles really quick, get our pen back. In the numerator, I see adding and I see multiplying, so we are going to have to multiply first. So I would have 2 plus on top. 4 times 3 would give us 12. Then in my fraction bar, under my fraction bar, I'm going to have to do the 2 squared first before I add. Again, just following the steps of order of operations here. 2 squared would be 4, 2 times 2. And remember, it's 2 times itself twice. And then I'm going to bring down that plus 3. Now at this point, all we have left to do is add in the numerator and the denominator. So we're going to go ahead and take care of that. 2 plus 12 is 14. And then on the bottom, we have 4 plus 3, which would give us 7. And then you see now that we have one number on the top and one number on the bottom, we can go ahead and divide. 14 divided by 7 does actually divide very nicely. We end up with a final answer of 2. Now, I will tell you, if you get a fraction and you have to, you can't simplify the fraction to a nice whole number, I do ask that you simplify the fraction. So for example, if this was 7 over 14, you would have to simplify both the numerator and the denominator by 7 to get 1/2. So no decimal answers right now. We're either going to get a nice pretty whole answer, whole number, or we're going to simplify the fraction. Okay, looking at number 5, I see parentheses, so we have to do what's inside of those parentheses first. We are going to do 6 minus 4 to get 2, and then when I do that, 2 is the only number left, so I can go ahead and drop those parentheses, but I'm going to bring the squared down, plus 4 times 3 squared. Now you'll notice on this one, our next step would be exponents, and I see 2 of them, but they're separate from each other, so I can do them both at the same time. So 2 squared gives me 4, and then I'm going to bring down this plus 4 times 3 squared is going to turn into 9 because 3 times 3 is 9. Then after that, we have to multiply first. So I'm going to bring down this 4 at the beginning, plus 4 times 9 gives us 36. And then last but not least, we're going to go ahead and add 4 and 36. That gives me 40 for my final answer. One more on the first page here, but you'll notice we have quite a bit of grouping symbols to pay attention to here. So the key about grouping symbols is you do have to work from the innermost out. So when I look at this, I see this set right here and this set right here. Since they are both separate from each other, we can do them both at the same time. So we're going to bring the 4 down. We're going to start our bracket. 2 times 9 is 18, and since that is one number, I get to drop the parentheses. Then I'm going to bring down this plus sign, and then we have 15 divided by 3 gives us 5, and since again that is one singular number, I get to drop the parentheses, but I cannot forget to bring that square down with it, and then close our bracket. So just in one step, all of those parentheses went away. Now, we do still have grouping symbols here, so we do still need to continue working inside of those. I see adding and I see an exponent. According to PEMDAS, we have to do the exponent. So I'm going to bring the 4 down. In brackets, we have 18 plus 5 squared, again, is not 10, it is 25. Remember, 5 squared is just 5 times itself twice, so 5 times 5. Next, we have one more operation to get the brackets all cleaned up into one nice pretty number. So we're going to go ahead and do 18 plus 25. So then I'm going to bring down this 4. And then I'm going to write 18 plus 25 is 43. Now we've been saying this whole time, when I get parentheses, brackets, any grouping symbol, when I get it down to one number, I do get to drop those brackets or parentheses. Now the problem is my answer is not 443. We have to think about what this 4 is doing on the outside. So if you remember, when there's a 4 on the outside, it's actually being multiplied by whatever's inside of the brackets. So if I'm going to drop the brackets on this last line, I do have to put a dot here. If I didn't want to put a dot there, I could keep the brackets and keep that multiplying, the implication of multiplication with just the brackets. But I like to put the dot here, so 4 times 43 is still my last step here, so I have 172 for my final answer. That is it for the front side. Let's go to the back. Okay, on the back side, we have number 7 here, problem solving. We're going to write and evaluate an expression. So looking at this, it is a word problem. Word problems in the past may have been scary for you, annoying for you, whatever it may be. But what we're going to focus on is really breaking down what this word problem is asking us to find. So it says, while she was on a 7-day vacation, Mrs. Razor boarded her dog at a kennel. If her boarding budget is $250, can Mrs. Razor afford, and we're going to highlight in a different color here, what is she going to purchase or what is she going to pay for? Can she afford an extra daily walk and 1 wash and nail trimming? Now, the other thing we have to make sure we pay attention to is she's on a 7-day vacation. So with that being said, let's go ahead and pay attention to, if she's going on a 7-day vacation, she obviously has to board her dog for 7 days. So I see right here that boarding her dog is going to cost $24 per day. So that is 7 days times $24. Now, when you're paying for something, we're adding up to find the total cost. So I'm going to put a plus sign here. And then she wants to add a few additional things, right? She also wants to have an extra daily walk. Now, since it says daily walk, it is $4 per day, just like it was $24 per day. So that would be plus, let's see, let me go with 7 here because that's how many days, times $4. Then after that, she also wants to purchase a wash, which would be $45. And then she also wants to purchase a nail trimming, so that would be $12. Now notice both of those amounts don't say anything about per day, so that's why we're not multiplying those by 7. Now, with this, we have to think about order of operations again. I see some multiplying and adding. Obviously, we have to do the multiplication and get that out of the way, so we're going to multiply those two numbers first. 7 times 24 would give us 168, plus 7 times 4 would give us 28, and then I'm going to bring down that plus 45 and the plus 12. Then after that, all I see is adding left, so I am going to do all of that adding at the same time. So then our final answer here is 253. Now, it's going to cost her 253 to do all of the things that she wanted to do. And remember what our original question was. If her boarding budget is 250, can she afford these things? So our answer here in this case would end up being no, she doesn't have enough money. Sad day for Mrs. Razor. Okay, that is it for number 7. So now we're going to start looking at number 8 through 11. This is evaluating algebraic expressions. So we're going to have to use the substitution property. This just means we substitute a value in for a variable. But something I want to make also very clear is when we use the substitution property, we have to use parentheses or brackets, but some kind of grouping symbol. We'll talk more in depth about why in a little bit. But using the substitution property to replace each variable in the expressions with the appropriate value. Now notice they tell us x is going to be 6, y is going to be -3, and z is going to be 10. So looking at number 8, they want to know what's 3 times x, right? If you remember, there's technically a dot hiding in there when it says 3x. So 3 times x would be 3 times 6, because x is going to be 6. Now this is what I was saying earlier. We are going to use parentheses when we plug something in or use the substitution property. Hear me out. I understand that a lot of you can probably do this in your head without ever showing work. But again, like I said earlier, I do make you show every single step. So something I am going to require is that you show me what you plugged in. I want to see exactly what your brain is thinking right now. Now, after that, it is just one step and you get your final answer here because the only thing to do is multiply 3 by 6. So then our answer here would end up being 18. Looking at number 9, we have y squared. Now remember, again, we're plugging -3 in for y, so we have to use parentheses. Notice the squared stays on the outside. So the only thing that goes inside of the parentheses is what you plugged in for the variable. So we have -3 squared. Now this is saying it's -3 times itself twice. -3 times -3. 2 negatives makes a positive, so our answer here ends up being 9. Normally we would be in the classroom right now having this conversation, but I would have you pull a calculator out and I would have you test this in your calculator with the parentheses and see what you get. Something that I will then also say is if you type in -3 squared in your calculator exactly like this in blue, your answer in your calculator is going to say it's -9. This would not be correct. That's why the parentheses actually make a difference. We will talk way more in second semester about why your calculator does that, what's actually happening there. But for right now, I just need to make it very clear you need these parentheses. Otherwise, you will get the wrong answer. Moving on to number 10. Again, showing what we're plugging in here, we have 4 times y, so this would be 4 times -3, plus we're going to plug in 10 for z. Now after this, I see that it's 4 times -3, which would give me -12, and then plus just 10. At that point, I can go ahead and drop the parentheses. Same idea as before. There's one parenthesis there, nothing to multiply with, nothing to divide with, so we can go ahead and drop them. And then final step here would be to add -12 and 10. That would give me my final answer of -2. And then for number 11, we need to be very careful here. We need to make sure we pay attention to what's actually being done here. This is x times y to the 4th. So we have x is 6 in parentheses, and then y gets its own parentheses, and then we have the 4th power. Again, the exponent always stays on the outside. It's not going on the inside with it. Now, making sure we understand what's happening here, this is 6 times -3. Multiplying does not happen first in PEMDAS in comparison to exponents. So we do have to take care of this exponent first. It is negative 3 to the 4th power. Again, having to be very, very careful about including the parentheses in your calculator. If you don't, you will get the wrong answer. So if you type this in correctly, it should be 6 times negative 3 to the 4th is 81. Oh, let me also, I forgot to talk about this earlier. When you go to type in negative 3 to the 4th power, most of you have a calculator that has a button that looks like this. We call it a caret button. So you'll type that in. So what you'll do is you'll do negative 3 in parentheses, push the caret button, and then type in the 4. This is what you should be entering in your calculator to get 81. Now again, that is most of you. If you don't have a button that looks like that on your calculator, please, please, please come see me and I can show you how to do exponents on your calculator if you are unsure. But with that being said, 6 times 81 would give us 486 for our final answer. Whoops. Now we have 12 through 14, same exact idea here, but you'll notice that these are a little bit longer. So again, we have to be very careful about parentheses and all of that stuff. So looking at number 12, now also notice they changed the values on us. So please make sure when you're doing your homework, you pay attention to if the directions have changed or whatever it may be, make sure you pay attention. So with that being said, let's look at number 12 here. So we have 2 times x would be 2 times 6, again in parentheses, plus 3 times y would be plus 3 in parentheses 8, and then minus z. So z gets its own parenthesis, and it looks like this. So first things first, I see 2 sets of multiplying. I can go ahead and do that at the same time. So 2 times 6 would be 12, plus 3 times 8 would be 24. Now, pay attention here because that's technically 2 negatives in a row. 2 negatives actually makes a positive, so this is really plus 3. If you also remember from a long time ago, this is technically a hidden 1 here. So in reality, it's negative 1 times negative 3. Still, 2 negatives makes a positive. So no matter how you look at it, that does become a plus 3 there. So then all I have left is adding. We can go ahead and add all of those together at the same time. 12 plus 24 is 36. Plus 3 would be 39 for our final answer. Looking at number 13. Now, this is something I like to also make sure I say. When there's parentheses and I have to plug values in for variables, I like to turn the current parentheses into brackets because what I end up plugging in gets its own parentheses. It just makes it a little bit easier to look at, a little bit cleaner in my opinion. However, if you would rather keep the parentheses, you are more than welcome to keep those as parentheses. So this is going to look like this, where we plug 5 is going to stay the same, but then times 6, and then minus, this is where I'm going to make that a bracket instead, and then I have y, which is 8, but that gets in parentheses, and then plus 2, and then in parentheses negative 3, because again, whenever we plug something in for a variable, we have to use parentheses. That is a requirement. That is something that I will be grading, so you need to make sure you have those parentheses. So then from here, I can actually do this 5 times 6 and go ahead and get 30 because it doesn't have anything to do with the brackets. But technically speaking, according to PEMDAS, we are supposed to do grouping symbols first. So looking inside here, I see an 8, but there's nothing to do inside of those parentheses, nothing to do inside of the parentheses with the negative 3. So then really, I just need to ask myself, am I going to add first or am I going to multiply first? And the answer ends up being multiplying first. So we're going to keep the bracket. Now, since the 8 is technically by itself, I'm going to go ahead and drop the parentheses there. And then I have 2 times negative 3 gives me a negative 6. Now, something I want to make very clear. This plus sign does not automatically get brought down. We are never, ever going to put plus a negative. We cannot put 2 signs in a row. It is either plus 6 or minus 6. Never, ever, 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 ever plus a negative. That is something that you would lose points for because those signs are not simplified enough. So I get negative 6 here, so then that ends up being minus 6 there because of this negative right here. And then after that, I have 30 minus 8 minus 6 is 2, and at that point I can drop those brackets. So then my final answer here would end up being 28. And then number 14, last one for this section, plugging in y would be 8 plus x is 6 and z is negative 3. So I have 8 plus 6 times negative 3. That's what's happening between x and z here, remember, and then all divided by 2. So I need to get the numerator, all simplified to one number before I can divide anything by 2. So I'm going to leave that 2 alone. And I'm going to look at, again, we have kind of the same situation as we had on number 13. I need to look at, am I going to add first or am I going to multiply first? And again, in this case, we're going to multiply first. So I'm going to drop the parentheses around the 8 because there's nothing else to do inside of those parentheses. And then plus 6 times negative 3 would end up being negative 18. This is exactly what I was just talking about a second ago. I did this on purpose. We cannot have plus a negative. It is not simplified enough. We are never ever going to allow to have 2 signs in a row. So if it's plus a negative, in reality, it is just a big minus sign and then all over 2. And then we're going to do 8 minus 18 gives us negative 10 and then all over 2 still. And at this point, now that I have one number on top and one number on the bottom, I'm going to go ahead and simplify here. I get negative 5. And we have one more word problem here. And I did just play back a little bit of this audio and I realized the fan on my laptop has been incredibly loud. I don't hear it while I'm recording my video, but I apologize for that little bit of annoying background noise. Hopefully it hasn't been too much of a bother. I will try to figure out what's happening before I record any other videos. But we only have one more problem to go, so hang in there for me. Olathe South High School has 100 more than twice as many students as Olathe North High School. Part A says write an expression to find the number of students at Olathe South if Olathe North has X students. So, starting with Olathe South, they have 100 more than. We need to think about what more than means. More than means plus. Twice as many means multiply by 2. So we need to take the amount of students that North has. They have X. That's all we know. So we know that twice as many as North would be 2X. And then 100 more than that would be plus 100. So that is our expression we're going to use. And then part B says how many students are at Olathe South if Olathe North has 1,000 students. So now we're going to actually plug that in. So using our expression, we have 2, and then in parentheses we have 1,000, and then we're going to add 100 to that. So then we have order of operations again. Are we going to multiply first or are we going to add first? We are going to multiply. So we have 2 times 1,000 would be 2,000 plus 100 would then be 2,100 for our final answer here. Now, this is a word problem, so we do have to answer in words. So what did we just talk about? What did we just find? 2,100 what? Ladders, cookies, apples. What are we talking about? The answer would be students. So there are 2,100 students at Olathe South. And that is it for these notes. I apologize again about the fan from my laptop. I will try to get it figured out. But thank you for putting up with it. And like I said, that's it.